Good day, thanks for joining me. This is Adobe Fikemba. I told you in this channel, I'll teach you physics, chemistry, biology. And today, we're going to be learning physics. And in physics, we are looking at dimensional homogeneity. Dimensional homogeneity deals with all terms separated by plus and minus in any physical equation in physics. Dimensional homogeneity. The validity of most formula in physics is anchored on dimensional homogeneity. Dimensional homogeneity will help us to be able to find what? Errors. Not only that, it will also help us to find unknown units in physics. Now, there are three cases I want to show you in dimensional homogeneity. Number one case is when we have case 1. When we have A is equals to B. In this case, it means that the dimension of A must be equal to the dimension of B. Let's look at case 2. Case 2, A plus or minus B is equals to K. In this case, when you have something like this, it also means that the dimension of A must also be equal to the dimension of B. And case 3, which is the last case I want to show you before we take an example. Case 3 is now what? A is equals to BC. In this case, it simply means the dimension of A must be equal to the product of the dimension of B and the dimension of C. Is that taken? Now, let's look at an example now. For example, let's apply. Example, follow me. Example, if the period of oscillation is the period of oscillation of a simple pendulum, period of oscillation of a simple pendulum, okay, the period is what? T, is related to the mass of the ball, So you put small n here, representing mass of the ball, comma, length of the thread. Follow me. Length of the thread. So in the length of the thread, you put small l, and the acceleration due to what? Gravity. You put small g, and the acceleration due to gravity. Full stop. The relationship is given as T equals to K mx raised to power x, L raised to power y, and G raised to power z. Find the value, I hope you can see, thank God. Find the value of x, y, and z. Derive a formula. Okay, so there are two questions in it now. So we'll first of all find the value of x, y, and z from this what? From this relationship given to us. So let me clean this now so we start solving. Then I write the relationship up because I want you to see clearly. Just follow me. Sorry if I'm fast, but you can watch the video over and over again to be able to do what? To be able to catch up with what I'm explaining. Okay, so the relationship is given as T equals K n raised to power x, n raised to power y, and g raised to power z. I hope that was the relationship that was given earlier on. Now, in this case, in dimensional homogeneity, and we've already talked about dimensions. The first thing to do is what? Step 1. Write out your parameters. Write out parameters. Okay? So, in writing out parameters, what are we going to do now? Well, we see this n. N is what? For mass. So, you write out your parameters and state its dimension. State its what? Its dimension. Okay? I hope you can see up to that point. State its what? Dimension. So, mass. What is the dimension of mass? Capital N. What is the dimension of length? Okay, small l, length. Okay, what's the dimension? Capital L. Are you following me? Now, what is the dimension of acceleration, okay, due to gravity. What is the dimension? The dimension of acceleration due to gravity is LT minus 2. Okay, meter per second square. This one is representing meter. L, meter for length. Then per second square, which is the what? Okay, let me write it there so you can see. So A is LT minus 2. L is representing meter. This T is representing 2, which is meter per second square. This minus is representing the part. Go and watch my previous video on dimension, or watch physics 1 to this part. This is part 10 of physics I'm taking now. Go and watch it. You understand how I got all this dimension, so that we can move on fast. I want the timing to be less. I don't want it to be more. Okay, having done that, we've written out the parameters. The next thing is step 2. Step 2. If you're not following me, I'd like you to follow me. You get more videos. By the grace of the Almighty God, I will teach you physics, chemistry, and biology. You will definitely make A1 in those subjects. 2. What do you do? Step 2. Substitute. Substitute the what? The dimensions in the equation given. In the equation what? Given. So in this case, all these dimensions we've written out, we will now substitute it and do what? Put it in this equation given. So let's substitute it now. So T is equals to what? K. What is our M? Capital letter M. We now put M raised to the power X. Okay. What's L? Capital letter L raised to the power Y. And what's G? L2 minus 2. So you have LT minus 2. But in this case, you cannot just write LT minus 2 and put Z. That would be wrong, because of this guy, which is a product. So this dimension must be equal to this. So what do? You put a bracket here and put your power, which is Z. All these things are raised to the power of this what? These values, expected values we are supposed to get. So what do we do next now? The next thing we begin to do is to, first of all, collect terms or make sure the terms are single. Step 3. Okay? Just put it, collect terms, collect like terms. So if we are collecting like terms now, what does that mean? It means we now say T, I hope you're seeing, okay, good, you can see. T is equals to K, M raised to the power X. What is common here? This L and this L, we want to make sure the terms are constant. M raised to the power, then L raised to the power Y, then we'll break this out. This Z will affect this. So it will now be L raised to the power what? Z. And T raised to the power minus 2Z. With this now, we want to make all this guy to be single. So we have MLT. So that's how to collect them. So I will clean up now. Now, the next thing is to now do what? Is to now, yes, we're still collecting terms. So follow me. We're still collecting terms. So the next thing we'll do now is, you bring this up to T is equals to K. Then you write M raised to the power X. Now, since the base are the same, it means the powers will be added. You understand what I'm saying? The base are the same, the powers will be added. So you have M raised to the power X, then you come here and say L raised to the power what? Y plus Z. Do you see it now? Then you now write your T raised to the power minus 2Z. With this, we've been able to make sure this guy, and this guy are single. So you can start equating. So let's start with M now. Now, according to the law of indices, anything raised to the power of 0 is equals to 1. Is that not taken? Anything raised to the power of 0 is equals to 1. But let's start with T, since we can see T. You know, this T is the same thing as T raised to the power 1. You know that anything raised to the power 1 is still that value. So you can come here and equate and say, therefore, T raised to the power 1 is equals to what? T raised to the power minus 2Z. This base will cancel, leaving the power. So you have 1 is equals to minus 2Z. Make Z the subject of formula by dividing it by minus 2 minus 2. What do you have now? Therefore, Z is equals to what? Minus 1 over 2. Keep it. Are you with me? How many minutes is this video? Oh, 9 minutes. You just have to, please, I'm sorry, bear with me. Let's continue. If I break it now, you might not understand. Okay, Z is minus 1 over 2. Then let's move to the next one now. And I told you that anything raised to the power 0 is 1. So let's go. M raised to the power 0 will be equals to M raised to the power X. Because since there's no M here, so we have to bring an invisible M. and raise it to the power of 0, which means 1 times this t will always be t. It's just like I'm saying, and look at what I just did. I did m raised to power 0, okay? Then l raised to power what? 0, and t raised to power 1. Anything raised to power 0 is 1. So this is 1, this is 1, and this is t raised to power 1. 1 times 1 is 1, and then 1 times this t raised to power 1 will still give you t raised to power 1. So I'm explaining how you can bring the dimension to equate to be able to get your power as your final answer. So let's continue. So in this case, I will now say m raised to power what? 0 is equals to what? M raised to power x. I will cancel m, cancel m. Therefore, x is equals to 0. Do you see? X is equals to 0. This is how I got x. Now let's look at how I'm going to get the next one, y plus z. So the next thing I will do is l raised to power what? 0. The same thing. Because these dimensions were not in this other part of the equation. So I have to raise it to 0 so that it can always represent 1. Anything raised to power 0 is 1. 1 times this original value here will be the same thing. So l raised to power 0 will now be equals to, follow me, I hope you are enjoying the class. L raised to power 0 will now be equals to L raised to power y plus z. Already we've gotten z somewhere to be minus 1 over 2. So this L will go. What do you now have? 0 is equals to y plus z. Are you seeing it now? 0 will not be equals to what's y? We don't know what y is. Y will not be plus times minus plus bracket minus 1 over 2. Plus times minus is still minus. So it will be 0 equals y minus 1 over 2. So when you want to bring it here, y will automatically turn to 1 over 2. Can you see it now? So therefore, x is 0, y is what? 1 over 2, and z is minus 1 over 2. I hope you can see it. Good, you can see it. So z will be minus 1 over 2. With this, we've solved the first equation. We've gotten the value x, y, z. Now let us now take these values, put it back into the what? Put it back into this, what's it called? Put it back into the related equation. You know, the related equation was, related equation was t equals k m raised to power x, m raised to power what? M raised to power what? Y. And, g raised to power, z. Is that true? G raised to power z. This is the related equation that was given to us. Okay? So now, what I want you to do, I will create another video again. I want you to solve this out and then derive a formula from this. Okay? Derive a formula from this. I'd like you to follow me if you're not following me so that you can get more video. After now, we'll be looking at chemistry. Thank you.